All right, so we're going to talk about some triangle theorems, and the first one that you should have learned from 7th grade is triangle sum theorem. So this one is pretty simple. In a triangle, the three angles inside a triangle should add up to 180. So what I'm going to put here is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. So it's a pretty easy formula to use, but I'll show you how you might see this in the 8th grade level. So ideally, this would be an example you may have seen in 7th grade. So you're given a triangle, and then you're given two of the sides, and you're being asked to find the third side x. So what does this third side right here measure? And, well, the way you would find that angle is, well, there's several ways. I want to show you this way first. So this is probably the more typical method that you would try. So some students would tell me, oh, well, you add the two you know, and then you take that away from 180, and that should be the third angle. And yeah, that would work. So if I do 71 plus 56, I know those two measure 127. Now, if all three add up to 180, well then I take away the two I do know from 180, and that must be left with my third one. So my missing angle, you could say, is 53 degrees. Now, I'm going to do the same idea, but I want you to set it up as an equation. So when I say angle 1 plus angle 2 plus angle 3 equals 180, I would like to see it set up this way. So I would say that 56 plus 71 plus x would all add up to equal 180. And then what I would want is for you to solve for x. Now notice how I'm going to solve for x. I would add 56 plus 71, which I know is 127, plus x is equal to 180. And then next, x isn't by itself, so how do I get rid of 127? Well, you would do the inverse, minus 127. And what I do to one side, I do to the other. Now, when I solve for x now, x is equal to, well, I already did the work. What's 180 minus 127? I get 53. So x is equal to 53. So my final answer here, the measure of angle x is 53. And then the way I went about solving it is kind of how you would do it on your own, but I want that equation set up. Now, final little piece of advice here is double check your answer. Keep in mind that what should all of these three angles add up to? Well, triangle sum theorem says they should add up to 180. So as a quick way to check, I'm going to do 56 plus 71 plus 53, and notice that they add up to equal 180. So I know that my answer is right because triangle sum theorem would prove it. Now, let me show you how this would look in an 8th grade level. So we have something like this. Instead of these pretty numbers, these pretty angles, I would give you something a little more complicated. So I would say 4x, 7x plus 6, and 64. Now I'm not asking any particular question here, so I want to show you what they can do. What I want you to do first is I want you to tell me what x is. So how would I set up an equation for this type of problem? Well, according to triangle sum theorem, angle 1, so I would say measure angle 1 plus measure angle 2 plus measure angle 3, they should all add up to equal 180. So instead of saying measure angle 1, 2, 3, let's change those to what they actually say here. So I would rewrite this as 4x plus, what's in place of measure angle 2? Well, that would be 7x plus 6. So plus 7x plus 6. And then what's going to be in place of measure angle 3? Well, plus 64. All of these three should add up to equal 180. Now, from here, I'm going to go through like a shortcut route. Just keep in mind, if you're getting ready for high school, you want to do this by hand, but for time, one of the tricks you could use on your calculator is going to be called solver. So for this case, we'll go ahead and use that. So solver basically just solves these basic equations for you. So the way you get there is you go to math, you move up to solver, and just type in the first side of my equation, which would be 4x plus 7x plus 6 plus 64. And all of that is equal to, so the other side of the equation, 180. And using this route, I would figure out that x is equal to 10. So if the question was, given this triangle and these angles, what is the value of x? That would be it. I'm done. Now, what would you do if I asked, though, what's the measure of angle 1? So what I need you to see is from here, you would go to your measure angle 1, and measure angle 1 was equal to 4x. Except now you actually know the value of x. So I want you to substitute the x. So instead of 4x, what are you going to put in place of the x? 10. And so what's 4 times 10? Well, that would be 40. So measure angle 1 is 40. So over here, this angle must measure 40. Now, if I ask you for measure angle 2, you do the same idea, except in this case, you would substitute the x in this equation. So 7x plus 6 would really become 7 parentheses. And what am I going to put in place of that parentheses, in place of my x? Well, x is now 10. So what's 7 times 10 plus 6? And I would get 76. Let me line that up. Now, one final thing again to check your answer is, what should angle 1, angle 2, and angle 3 add up to? 180, right? That's triangle sum theorem. So what I'm going to do here is, well, measure angle 3 is 64, right? Add them all up. What should 40 plus 76 plus 64 be? And if I go check, well, what's 40 plus 76 plus 64? And I would get 180. So this is what I wanted to happen. So using triangle sum theorem, you can set up equations, and then you can use that to actually solve the missing angles, depending on what it asks for. So here's a different version of the same type of problem. So they can be in different forms, different styles. Yeah, I'll go over one more here. So I'd want you to find the missing angles as well. Find measure angle 1, 2, 3. Now the way I give them to you, well, I don't know what they measure, but I do know that if I add angle 1, which is 7x plus 4, plus angle 2, which is 5x plus 3, plus angle 3, which is 2x plus 5, I know that they would all add up to 180. And then from here, I could use solver again. So I'll go ahead and set that up real quick to solve for x. So I'll go to math, solver, and then you would just set it up the way you have it written down. So 7x plus 4 plus 5x plus 3 plus 2x plus 5, and all of that would be equal to 180, so I'll just leave that 180 I have in there. And then when I go solve it, keep in mind this 10 is the answer that I left in there from the last time. So when I go and press alpha solve, my new answer is 12. So in this scenario, x is equal to 12. And again, I'm using solver. It'll get you through the 8th grade, but you should know how to do this by hand for Algebra 1 in high school. Now, go and do the same process. Find me measure angle 1, 2, and 3. But instead of saying x, you're going to go and substitute your x value. So for measure angle 1, I'm going to set it up as 7. I'm not going to put the x. I'm really going to put the 12 in place of x. And what's 7 times 12 plus 4? So I'll work this out on the calculator. So what's 7 parentheses 12, so times 12, and then plus 4. And so measure angle 1 would be about 88 degrees, or it is equal to 88. And then I'd move on to measure angle 2. So measure angle 2, I'd follow 5 parentheses plus 3, but in that parentheses I would use my 12. And what's 5 times 12 plus 3? So 5 times 12 plus 3, and I'd get 63. So this one's equal to 63. And then finally, measure angle 3. So measure angle 3 says here is 2x plus 5, but notice what I'm going to do in place of my x. I'll use my 12. So what's 2 times 12 plus 5? And so I'll set that up one final time. So what's 2 times 12 plus 5? And I end up with 29. So I have all three angles, and as a quick double check, what should all three angles add up to if I'm going to check this with triangle sum theorem? Well, they should add up to 180. So let's do 88 angle 1 plus 63 angle 2 plus 29 angle 3. And do I get the answer that I was expecting? Yes. And the reason I know I'm right is because I used triangle sum theorem. All right, so here's the first one, right? So we got triangle sum theorem. Now, let's go ahead and take a look at exterior angle theorem. Okay, so on this one, it looks a little bit different. It looks something like this. And hopefully the name makes sense, exterior angle theorem. So you have these here. These are going to be considered our interior. And I want to focus on this one out here, which we're going to refer to as our exterior. So I'll call it angle 4. Now the way this rule works is your non-adjacent interior, or I should say interiors, is equal to your exterior angle. Now the exterior angle obviously has to be angle 4. It's the only angle on the outside. Now, which ones are my non-adjacent interiors? Well, you know it has to be something to do with these three angles inside. Now, the word adjacent means right next to, so non-adjacent would mean not right next to. So when you're looking at angle 4, I want angle 4 equal to the non-adjacent interior. So of these, which ones are not right next to it? Well, 3 is right next to it, so I don't want the 3. But angles 1 and 2 are non-adjacent. So one way to set up this formula would be to say measure angle 1 plus measure angle 2 is equal to angle 4. And it's as simple as that. Now, there are other ways to figure out these angles. Like for example, angle 3 and 4, they make a straight line. So as a side note, I might want to mention that there's supplementary that could be involved. There's always a bunch of ways to get to an answer, but for right now, I want to focus on this. My non-adjacent interiors are equal to my exterior angle. So here's an example of one. Almost the same type of setup, but now I have some actual numbers. So can you solve measure angle x? Well, if you're comparing this rule to the previous one, it's simple. This exterior angle, right, is equal to the two non-adjacent interior. So do I have my non-adjacent interior angles here? Yeah. So this one's going to be as simple as 126 plus 24 is equal to my exterior angle. So x must be, what's 126 plus 24? That's 150. So it's as simple as that in this case. Okay? Now, for 8th grade level, we wouldn't leave the numbers this simple. Okay, we want to make them a little bit more complex. So let's take a look at something a little bit fancier than this, but the way I want you to solve this is to use the exterior angle theorem. Non-adjacent interiors equal to the exterior angle. All right, so here's our fancier example. So they might look something like this. In this case, what I've done is I've extended my triangle so that there's 3 exteriors this time. But it's easy to focus on, so we'll see how it looks in a bit. All right, so I'll go ahead and label it like this. And I want us to solve, well, all the angles actually. So what's x, what's y, what's angle z, and then what's angle 4? Now, here's the approach that I'm going to take. Let's say I want to start off with x. So if I want to start off with x, I need to know that x, using the exterior angle theorem, is equal to the 2 non-adjacent interior. So the 65 is adjacent, so I don't want 65. So for the x, I would use the 30 and angle 4, but I don't know angle 4. Or do I? You see, what I could do is, well, shouldn't these 3 angles add up to 180? So I can solve that using triangle sum theorem. All right, so I'll come back with this. Let me set this up right. All right, so all right, here you go. Hopefully you can see that. So let's go ahead and do the 2 angles that I do know, 30 plus 65. And I know that all 3 should add up to 180. So if I get the 2 I do know, subtract it from 180, then my missing angle must be 85. So this angle here, we're going to say measures 85 degrees. And if you're doubting that this one here measures 85, then I'll simply check by doing 30 plus 65 plus 85. And if I'm correct, what should all 3 answers add up to? 180. So I know I'm good. Now, let's go back to the exterior angle theorem. Angle x is equal to the 2 non-adjacent. So that would be 30 and 85. So what is 30 plus 85? And a quick calculation, 30 plus 85. My answer here would be 115. So this is how you would use the exterior angle theorem. Let's go ahead and do the rest. Now, focusing on angle y, well, angle y is equal to, which are my 2 non-adjacent interior? It's not the 30, it would be the 85 and the 65. So angle y is equal to 85 plus 65. And so what's 85 plus 65? And I get 150 in this case. And then finally, what's the measure of angle z? So which ones are its non-adjacent interior? So that would be the 2 that are not next to it on the inside. So that would be 30 and 65. So angle z would be equal to 30 plus 65. All right, so what's 30 plus the 65? So that would be 95? And there you have it, exterior angle theorem. So it's a little bit more because there's 3 exterior angles, but it works all the same. So we want to make sure we're focusing on this wording right here. Non-adjacent interiors are equal to the exterior angle. So the 2 that are not right next to it are the ones I want to be adding up. So we'll take a look at a slightly fancier one. By that I mean these. So are we okay with these when they put those fancy algebra stuff, right? So it's the same idea. I want you to solve for x. So let's solve for x first. So the first thing I would do is I would notice, okay, so I have an exterior angle and then I have these 2 on the inside. So this has something to do with exterior angle theorem. And well, exterior angle theorem says that the exterior angle, that would be 153 in this case, is equal to my 2 non-adjacent. So which ones are my non-adjacent? My 2 not next to it. That would be 3x plus 5 plus 2x minus 7. And let's go ahead and solve for x. So I would go ahead and take the shortcut route in this case. And I'd go to math, solver, and in this case I would start off with 153, and on the other side 3x plus 5 plus 2x minus 7. And don't forget to press alpha, enter. And so in this case, x is equal to 31. So x equals 31. If the question were, what is the value of x, I would be done here. I do want to go a little bit further because they may ask, what's the measure of angle 2? Well, to solve for the measure of angle 2, I would have to go in there and substitute the x. So what's 3 parentheses plus 5? And in that parentheses, I would replace it with my 31. So for measure angle 2, what's 3 times 31 plus 5? And so that answer would be 98. And for measure angle 3, this one, well, I'd go ahead and set up 2 parentheses minus 7 to get that the x is 31. And here we go. So what's 2 parentheses 31 minus 7? And so I have 55. So I have 2 of my angles now. Now it doesn't ask me for angle 1, but I do want to point out that if I want to check my answer, 53 should be equal to, well, this one turned out to be 98, and this one turned out to be 55. Well, then 153 should be equal to 98 plus 55. So it'd be kind of nice to go and check that answer, right? So what is 98 plus 55? Does that give me the 153? Yeah. So right here I have my 153, and it's true. My exterior angle is equal to my non-adjacent interior. Now, just to find the missing angle, the angle 1 here, let's go ahead and, well, I have 2 options actually. You see here you have your supplementary angles, or you could use triangle sum theorem. So just to mix things up, I'll use supplementary. So if angle 1 and angle 4 should add up to 180. But if I take away the angle I do know, 153, that'll leave me with the remaining part. So angle 1 is actually 27 degrees. And I could check this answer by, well, what should these 3 angles add up to? What is 27 plus 98 plus 55? And notice I get 180. Okay. All right, so we've had triangle sum, exterior angle theorem, and then there's one more theorem I would like to talk about. Or it's actually not called theorem. It's going to be called angle-angle similarity. So the definition here is a little bit lengthy, but it says if 2 angles of a triangle are congruent to 2 angles of a different triangle, then they're similar. So here's what I mean. Notice how I marked these. So this single mark here would be corresponding to this angle, and then this double mark would be corresponding to this one. And so if I were to give you 2 angles like this, right, notice that 60 is congruent to 60, 47 is congruent to 47. What I would have here is 2 angles congruent to 2 angles of a different triangle. So that would mean that these 2 triangles are similar. Now, that's all this topic really talks about. But what I want to go ahead and make sure I mention is similar triangles are proportional. In fact, I should say similar shapes are proportional. And the reason I mention that is because you get a lot of questions that come out of here from the 8th grade exam, where they want you to use similar shapes or similar figures or triangles or whatever type of thing similar to set up proportions. And I have a lot of students that have trouble with this, so I'll simply extend a little bit past this to show you what it would look like. So you have something like this where you're missing angle x and you're missing side y, side x, side y. Now, if I tell you nothing else, how do you know that these are proportional? Well, because I have two angles of one triangle that are congruent to two angles of another, then these triangles are similar. Now, with that being said, similar triangles are proportional. So one way I could set it up with the proportion is, let's say somebody told me, well, when you set up something, it has to be corresponding. So let's say I set up 5 over 20. Well, 5 corresponds with 20, so that's fine. You can do that. What else would I have to set up on the other side to solve for x? Well, you have to be careful. If you started off with 5 over 20, you have to pick corresponding sides, like the x and the 6. But I decided already to start off with small triangle to the big triangle. So if I'm going to set up the other side, I got to start from the small triangle, so the 6, to the big triangle, which would be x. And from here, I could cross multiply and then divide. So if I were to solve for x, it would be 20 times 6 and then divided by 5. So in this case, x is equal to 24. And again, I'm only able to set this up because they are similar, which is my main focus on this. Similar triangles are proportional. And the only way I can say they're similar is if two angles of one are congruent to two angles of another. And then finally, the last one, if I were to solve for y, so I know x now, if I were to solve for y, there's a bunch of ways to set up proportions, just gotta be careful. Let's say I decide to go with 5 over 4.5. So I decided to use 5 and 4.5. Now my corresponding sides would be 20 and y, but the order you put them in matters. So 5 corresponds to 20, so I'll put the 20 on top, and 4.5 corresponds to y, so I'll put the y at the bottom. So if you cross multiply and divide these, what's 20 times 4.5? And then divided by 5. So y would be 18. Okay, so you got 3 ideas: angle-angle similarity, exterior angle theorem, and triangle sum theorem. Okay, so if you can use this video to refresh on these